right, so here we are, pre-calculus 30, and this is 6.3, proving identities. All right, so this is number 37 from the handout assignment. So if you have something like this and you're asked to prove this, again, we want to make one side look like the other side. And so on the right, you see all the identities here from the chapter. And so we're going to use some of these to transform bits and pieces of one of these sides to transform it to make it look like the other, of course. So I'm going to take a look at, you can start with either side. Usually you start with the side that's a little bit more complicated, I guess, the more complex side. It's tough to tell which one's the more complex side, but I think there's a little bit more to work with on the left. So I would probably start with the left. So what we're going to do is we're going to look and see if is there any factoring we can do, obvious factoring. Is there any, are there any indicated operations, like are we asked to add or to multiply something together that we can actually do that might help? Or are there any identities that we see right away that we could transform? And I see the fact that I have sine squared, and so sine squared actually equals, if I move the cos over to this side, which you can do with identities, you can rearrange them, sine squared equals 1 minus cos squared, okay? So that's what I'm going to do. I'm going to write the top out here, and I'm going to change sine squared to 1 minus cos squared theta. Now, why would I do that? I would do that because I can now see that this is a difference of squares. See, a perfect square, it's a difference. So I can factor that. And that's going to be able to be factored. Okay, and I'll rewrite the top here. That's going to be able to be factored into 1 minus cos theta times 1 plus cos theta. See that? So again, how do you go about this? Spy out something that is on your identities sheet. Transform it. Now take another look at it and say, hey, what can I do with that? Oh, difference of squares. Let's factor that. Now you can see that I actually have this factor and this factor. Okay, so those can go together as factors. They're binomials, binomial factor of the top and the bottom. They can cancel out. Now I've got 1 over 1 plus cos theta, which is exactly what I'm looking for over here. See that? So there you go. It's just a couple steps and you're done. Now another way to look at this, what if you chose the second side? No problem. If you chose the second side, you would be like, well, I don't see an identity in there anywhere. Well, you could go number 1, I guess. Look at this, 1. You could write that as cos squared plus sine squared. Now, if you did that, you'd have a tough time canceling anything out or rearranging things. That's kind of making it more complicated. But the one thing that you could do is you could always multiply by a conjugate to make a difference of squares. And a difference of squares is often a very, very good thing because look at, we have secant minus 1, secant squared minus 1. That's a difference of squares. We have cosecant squared minus 1. We have 1 minus cos squared and so on. So we have lots of difference of squares that we can use from the identities. So this one's going to be, if I multiply the top, well, that's just 1 times this, right? And the bottom, look at this. Now I have a difference of squares. That's what multiplying by the conjugate gets you. 1 minus cos squared theta. Okay. Now we'll keep in mind, this is what we're aiming for over here. And so 1 minus cos squared theta is what? Well, again, look at your identity right here. 1 minus cos squared equals sine squared. So this right here can be substituted for sine squared. And there you have it. And now you've made the right side look like the left side. Okay? So 2 different ways. When one side is not clearly more complex than the other, you often can choose any side you wish. So that's number 37.